Alright, Year 12, so here's a resource for you guys to use in preparation for the energy systems test. So I've just gone through those exam questions, and there's some types of language, things that you could use, reference to graphs, reference to concepts that you can check against what you have done as part of your homework. So first question, looking at completing that table. The table looks at three types of activities. Obviously, by the duration and the intensity, you could pick which energy system is being used and therefore the cause of fatigue. So the first activity, 4 repetitions, you're looking at high intensity, short duration, 10 seconds. So the phosphate creatine depletion would cause fatigue. The second one, marathon's easy, but just looking at causes fatigue when we're working aerobically, things like dehydration, glycogen depletion, maybe gradual lactic acid buildup could be those things. With the push-ups, you're looking at the 60 seconds of high intensity, so the lactic acid accumulation would be the cause of fatigue. Choose one of the activities. I've outlined in the previous answer, so you just need to go into a bit more detail there. Use the examples of how you figured out which energy system is being used. The question here, that's the exercise graph that we looked at the other day. 18-year-old student, it's got a steady state there. You can see over here they might have had an oxygen deficit stage and then the epoch stage over here. So if we're looking at what is meant by steady state in relation to the graph, you're looking at this part here where there's no real rise or fall in heart rate, where the oxygen demands are being matched by oxygen consumption. With reference to the graph above, explain one reason why E represents a steady state. You could look at the fact that they're only going up to 160 beats per minute. The student's maximum heart rate is 202, so they haven't reached that. Also, if you're working at max heart rate, you probably go over your lactate threshold, and you have to reduce that intensity. They're working at a steady state as well, which would mean there's no rise or fall in that intensity. Using data from the graph on page 10, explain how energy contributions change. So between minute 3 and 7, you can see here between 3 and 7, there's that real rise in heart rate in part D there. So there's an increase in heart rate. This would be the oxygen deficit stage where the lactic acid system would need to be predominant while the intensity increases. So once that athlete gets to the steady state, they can work aerobically. At the start of the exercise, they may excuse the acute physiological changes, so ignore that. That goes in the next concept. Question E there, the dominant energy system in epoch. So this stage here, this shaded area, that would be aerobic. So we're working it aerobically to recover, to replenish the PC and to remove the lactic acid. The student takes a 12-week plant training program. You might not know that. That's, again, a further concept, but what we're saying is that the epoch phase might become more efficient. All right, so another diagram here. We can see the novice triathlete as they, at a lower running speed, gets a higher blood lactate threshold. So they sort of had that rise at a lesser speed than the club triathlete. So identify the running speed where the club triathlete reaches its lactate threshold. You're probably looking here at about 5.5 meters per second. In the first race, the novice triathlete running speed of 5 meters per second. Explain the consequence of running at that speed. So we can see the obla occurs because we have an increase in blood lactate. What happens if obla occurs? We get a serious onset of fatigue, which the athlete would not be able to maintain that running speed. Of an elite athlete, you probably get a curve that, if you follow my cursor, would probably go up like that, where they could run at a higher meters per second before they would experience obla. Refer to the table which shows the men and women's world records. So ignore the first one about the physiological difference. That's physiological factors that affect performance. But explain the different use of fat and the fuel in a marathon compared to the 400 meters. So we're looking at the fat as a fuel in a marathon. It could be used as a long-term source of energy broken down with the O2, and we could spare glycogen to be used at a higher intensity of performance. where in 400 meters we wouldn't use fat because it's a high duration a high intensity short duration event, and we'd be using glycogen to be broken down without oxygen. So, explain the total excess body fat would be a disadvantage to a long distance runner. So, in terms of weight, it's harder to perform over a long period if you carry more body weight, but also excess body fat can hinder blood flow to your muscles. So, if we're carrying fat, the muscles need the blood and perform more efficiently with oxygen, so the less body fat, the better. Explain the possible cause of fatigue, impact on athlete performance. A 400 meter event, we're obviously looking at lactic acid build-up there. Here we're looking at a nutrition one. This is just simply reading the graph, so we can see that low-fat chocolate milk had delayed fatigue up to about 8 minutes there, with a recovery sports drink up to about 6 minutes. So that's just purely a reading the graph question. When we come here, explain one advantage of the combination of the carbohydrate and protein recovery drink. Well, we know if we take carbohydrates, they can replace the glycogen that we would have used within that event, and the protein would have aided with the growth and the repair of muscles post that event. So those are the advantages of having that combination. If we're looking at a disadvantage of the low-fat chocolate milk, again, just reading off the graph, I've mentioned 2.4 grams of fat and the restricting blood flow of the muscles. You could also mention something about the sodium. There's a higher sodium level there. So those sorts of things could be considered a negative. If we're looking here at this question, we have the elevation in the red and the heart rate in the blue. We can see here that the maximum heart rate sort of probably comes up to about here, which is about 180 beats per minute. Person who's running this may experience steady state. Again, we're talking about this idea of a steady state we talked about earlier, about oxygen requirements are being met. C, we could suggest that the likelihood might have exceeded the lactate threshold. Now I'm going sort of from this 11 to 12 mark, if you follow my cursor. Here the heart rate increased rapidly following a really increase in elevation. And that might have been they exceeded their lactate threshold there because they stopped post that. There's also bits here where they go up and down, but that's hard to explain seeing as the elevation doesn't actually go up and down, but that sort of rise and fall in heart rate could also suggest it. Ignore that D. E, if we're looking at the athlete's cause of fatigue in the last kilometre, so the increase in elevation could be a cause of fatigue because we'd have to use the lactic acid system more as the increase in the elevation happened. And then explain the athlete's effort in the last kilometre would affect on epoch. So the epoch would be extended. The example that Georgia gave the other week with her heart rate being slightly elevated for a longer period of time, not right back to rest, showed that lactic acid phase where we're removing that lactic acid over a longer period of time. Explain the interplay of energy systems. I'm just saying that stage B, some changes in elevation, you might have had your PC system working in that initial phase, lactic acid as you're showing increased intensity. They might have been chasing a pack or something like that because the elevation is not there, but during these lower phases here, the active recovery may have been happening. Alrighty, so hopefully that's helped. Hopefully that helps some of your revision, and good luck for the test on Wednesday.